Welcome all of you. So, give reasons for the following. This is unit test paper for chemical bonding class 10 ICSE. Ammonia gas is a covalent compound and does not conduct electricity, but its aqueous solution NH4OH is a weak electrolyte. Now this is little contradictory because ammonia is covalent. How is ammonia covalent and how and does not conduct electricity, whereas the same one when dissolved in water, that is NH4OH, is a weak electrolyte. Now ammonia is a covalent compound and that is the reason it will not have ions. It is one whole molecule. As you know, covalent compounds are one whole molecule. Okay. On the other hand, NH4OH can ionize. It will form NH4 plus and OH minus ions, and that will conduct electricity. So ammonia gas, being a covalent compound, does not conduct electricity, but NH4OH conducts electricity. MgCl2, that is magnesium chloride, is soluble in water but insoluble in acetone. Okay, so magnesium chloride, why is it insoluble? It is, why is magnesium chloride soluble in water? Magnesium chloride is ionic, it's an ionic substance, and so it is soluble in polar solvents. Water being a polar solvent, so it is soluble, and it is insoluble in acetone. Now acetone is an organic compound and it dissolves organic substances, while methane is insoluble in water. Methane being non-polar, it is insoluble in polar water and polar solvent water and soluble in acetone, because methane is non-polar and so it will be soluble in non-polar acetone. So the whole thing, if you see, is MgCl2 is polar dissolves iron displaces copper from a solution of copper salt. Okay, iron displaces copper from a solution of copper salt. Now this is a very common thing. Iron will displace copper. This is a displacement reaction, as you know, and iron is higher in the activity series than copper, so it will displace copper from a copper salt. The reaction is deemed as a redox reaction. Now, why does iron displace copper from a copper salt? Iron displaces copper from a copper salt because, as I said, it is higher in the activity series and copper is lower, so it will displace. Why is the reaction a redox reaction? The reaction is a redox reaction because copper gains electrons in the process, and gaining electrons is a reduction process. Okay, so copper gets reduced, iron loses electrons, and so it gets oxidized. And since reduction and oxidation both are happening together, so it is called a redox reaction. A non-metallic atom, atomic number 9, forms a molecule of the same containing a single covalent bond. A non-metallic atom, okay, it can be any non-metal. Here you are not asked to get the name of the atom. Forms a molecule of the same. Okay, so it forms a molecule of the same, means that is two atoms are joining up to form a molecule containing a single covalent bond. Now why is it so happening? Now if you see the electronic configuration of this, if you see the electronic configuration of atomic number 9, then it comes to 2,7, right? It comes to 2,7. If it is coming to 2,7, then it is containing a single covalent bond. It forms a molecule. Now first orbit 2, second orbit 7. So it will form a single covalent bond, just like fluorine or chlorine, because last orbit has 7. It just needs one more electron to complete its octet. So it forms a single covalent form, thus forming a diatomic molecule. In the formation of MgO, the magnesium atom loses 2 electrons from its valence shell. Magnesium will lose 2 electrons from its valence shell because the electronic configuration of magnesium is 282. So after losing 2 electrons, it comes to its more stable configuration. It comes to the octet formation of 2 and 8, which is a very stable condition. So it loses 2 electrons. Next question, with reference to molecule of water, fill in the correct word. Now here we are talking only about a water molecule. Water is a non-polar covalent molecule. Water is a non-polar covalent molecule. Okay, so in which the atom of water is a non-polar covalent molecule in which the atom of hydrogen, oxygen, in which the atom of hydrogen or oxygen. Now here atom of oxygen attracts electrons more strongly, it is more electronegative. The water molecule shows the presence of double, single or two covalent bonds. The water molecule shows the presence of two single covalent bonds with hydrogen, of course, and two pairs of lone electrons. Okay, so lone pair of electrons are the ones which do not go into any chemical combination with any other atom in a molecule. In the lone pair is found in the oxygen atom. So here you are going to write oxygen. Okay, complete the table below. Now what is the table below? Here complete the table below. Atomic number is 20. Element and B, element A atomic number is 20. Element B atomic number is an 8. The type of bond, what is the type of bond that will be formed between these two? Okay, so what will be the type of bond that will be formed between these two? The type of bond that will be formed between these two is a ionic bond. Why will it be an ionic bond? It will be an ionic bond because here it's going to be an ionic bond. Why will it be an ionic bond? If you see the chemical electronic configuration of this, it is 2882 and here it is 2 and 6. If so, then it forms an ionic bond because 2 electrons from A will be given to B, will be donated. So there is donation and acceptance. Now we can see one thing very clearly in the first one, that these two, out of these two, A is a metal and B is a non-metal. Okay, clearly, because the second one has, B has a valency of -2 and the first one has a valency of +2. Okay, so in that case we get in that case we get okay, the name of the compound is AB. Okay, the name of the compound is AB in this case. Okay, because valency is equal in both. Atomic number 20, second one, and C atomic number is 17. So 2882 and 287, and here also we have one metal and one non-metal with a big difference in electronegativities, and so here again the bond is going to be ionic and again it is going to be AC2. Okay, so it's going to be AC2. So this is going to be AC2 because in order to take 2 electrons from A, you need 2 different C atoms. So it is AC2. Now the next one is atomic number 9 and atomic number 9. That means it is the same element. It will form D2, just like we have Cl2, we have Br2. So like that, it is going to form D2, okay, where both of them is 2, 7 and 2, 7, same electronic configuration. It is going to form a single covalent bond. Okay, next one is atomic number 12, atomic number 16, then we have E and F. So 2, 8, 2 and 2, 8, 282 and 286. Okay, in that case it is going to be again valency -2 for F and valency 2 for E. So we are going to get an ionic bond because there's a big difference in electronegativities. One is a strong metal, one is a strong non-metal, and so there's a big difference in electronegativities, and so we are going to get ionic bond, which is EF formula. Okay, atomic number of G here, atomic number of G and atomic number of F. Atomic number of G is 1 and atomic number of F is 16, which is 286, and GF is going to form a covalent bond because here the one which has atomic number 1, there is no question of giving an electron. Okay, so it will enter into a covalent bond, which is going to be a 2 of G we will need because we need to fulfill 2 valencies. We need to fulfill, we need to, that 6 in the outermost orbit over here in this. Okay, the 6 in the outermost orbit over here needs to be made to 8. So we'll take 2 of these, 2 of G from here. Okay, that will make it G2F, G2F, not GF2. The bond between the two elements of group 17 of periodic table is likely to be, the bond between two elements in group 17 is likely to be it's going to be a covalent bond. Why it's going to be a covalent bond? Because if they are in the same group, they will have almost same electronegativities. Okay, therefore it's going to be a covalent bond. In the reaction Cl2 Ki KCl I2, the conversion of 2I to I2 is deemed as an oxidation reaction. The covalent molecule containing 3 single covalent bonds is the covalent molecule containing 3 single covalent bonds is ammonia. Okay, you have 3 nitrogens coming here with ammonia, so it forms a single covalent bond. The molecule of water combines with a proton. Okay, it is H plus. Why is H plus called a proton? Let me tell you that, because H plus means whatever one electron hydrogen had, that also it has given to somebody. Okay, so it is that plus because now it has only one proton, that plus positive charge is showing. So it is more than an atom, it is now just a proton. Okay, now if you don't have the electrons, then it ceases to be an atom, right? You have only the nucleus. Hydrogen molecule, so proton, hydrogen, not hydrogen molecule, sorry, to form the hydronium ion. So answer here is proton. Proton is the correct answer. For formation of electrovalent bond between X and Y, which are the metal and non-metal respectively? For formation of electrovalent bond between X and Y, which are a non-metal and metal and non-metal respectively, X should have a low IP ionization potential and Y should have a high electron affinity. Electronic configuration of the following elements are given. Now you can see some electronic configurations given. State which of the compounds given below have high or low boiling points and soluble and insoluble in organic solvents. Now here we have HCl has a very low boiling point. Okay, it goes to negatives and it is soluble in organic solvents. On the other hand, NaCl has a high melting and boiling point. It is an ionic compound, high melting and boiling point, and insoluble in organic solvents. Okay, CCl4 is soluble in non-polar substances, non-polar organic solvents. A compound has the formula H2Y. Now this type of question is very typical of ICSE. Y denotes the non-metal. State the following. Electronic configuration of Y. Now, electronic configuration of Y. Electronic configuration of Y can be, because we can clearly see the valency is 2. Okay, so electronic configuration of Y can be 2, 6, because it is the non-metal, so it has to be -2. Okay, the valency of Y is clearly a -2. The bonding present in H2Y, it is a covalent bond. We can see there are two single covalent bonds. The bond present in the compound between potassium and Y. Okay, now potassium is very strong metal. It's right to the left of the periodic table, and Y is to the right of the periodic table, not extreme right, but it is still a strong non-metal. In that case, we will have an ionic bond. Okay, we'll have an ionic bond. Formula of compound formed between calcium and Y. Again, calcium and Y will also form an ionic bond, but in that, the formula here is going to be Ca and Y, so both have valency 2, so it's going to be Cay. Okay, the previous one is going to be K2Y because valency of potassium is 1. Okay, so it's going to be K2Y, but the second one is going to be Cay. Okay, so I'll come up with more question papers. If you have liked the video, do not forget to like, share and subscribe. Okay, I'll be coming up with question paper of electrolysis next. Okay, so thanks all of you. Bye then.